In this video we're going to explore how to use the 𝗖𝗵𝗽𝗀 daemon in Linux. And Rsyslog, as it says here, is a rocket fast system for log processing, and it offers high performance, great security features, and importantly a modular design. And Rsyslog is designed to do many things, but here is a summary of the main ones. We can accept inputs from a variety of sources on our Linux systems. We can then optionally transform those inputs into a different representation, and then we can output the results to diverse destinations, and that's typically other files on the Linux file system, typically in a Debian based distribution under the var log directory. Now Rsyslog can also send logs over the network using the TCP or UDP protocols. What we're going to do in this video is we're going to show how to build a service that outputs to a log file, and how to use Rsyslog to take the logs from that source and then output those logs into a different location. And in a nutshell, that's what Rsyslog does. It collects logs from different sources, optionally transforms them, and then sends those logs to a different location. So let's dive in and get started. Now what we're going to do in this video is we're going to reference this guide that 𝗵𝗽𝗁 has written on Rsyslog. So let's scroll down here and we're going to look at the section here on how to install the Rsyslog daemon. So let's click that link on the left hand side and we're going to be taken to the installation section. Now what we need to do if we're using something like Ubuntu is install Rsyslog, in this case using the apt or apt-get command. If you're using a different type of system you might use the yum command, but I've got a terminal open here. I'm going to bring that onto the page, and this is using Ubuntu. So what we're going to do in this video is we're going to install Rsyslog. So let's copy this command and go back to our terminal, and we're going to install that now. And we're going to find that that's already installed on this Linux distribution, but if you don't have Rsyslog you can install it with apt using that command. Now once we've installed Rsyslog we can check the status using systemctl, and what we're going to do is use the status verb, and we're checking the Rsyslog daemon, and we can see that it's active. It's running on this Ubuntu distribution, and that means it's going to be looking at the log files that are generated by certain services depending on its configuration, and sending those logs to different destinations where they can be centralized. So now that that's running, we're going to go back to the 𝗵𝗽𝗁 guide, and we're going to look at this section on how Rsyslog works, and it contains this diagram here. Now let's zoom in on this a little bit. What we can see here is that we have certain inputs, for example the cron service and the SSH daemon on Linux, and there can be as many of these inputs as we need, and each one of them can be configured as we're about to see in the video. Rsyslog is going to monitor and collect the logs from this source, that's /dev/log, and it's going to forward those logs onto various locations, usually in the var log directory. Now if we look at the paragraph below, we can see that various applications like the SSH daemon and mail clients and servers and cron tasks, these all generate logs at frequent intervals, and they typically write log messages to the /dev/log file. So Rsyslog monitors this file, and it collects logs as they are written and redirects them to plain text files in the var log directory. And that includes the var log syslog file itself. Now the rules that determine where the logs are sent are defined in this file here. It's called 50-default.conf, and that's located in the /etc/rsyslog.d directory, which we're going to look at in a second. Now let's scroll down a bit further here. We're going to look at some of the modules that exist in the Rsyslog ecosystem. And these are modules for inputs and for outputs. So on the left hand side we can see some of the example inputs. We can get the logs from files, we can get it from Unix sockets, from TCP and UDP, and there are many more sources as well. Those logs are collected by Rsyslog and they are forwarded on to different destinations. And we have some examples here, for example PostgreSQL. We can also send logs to Redis, MongoDB, MySQL, Elasticsearch, and so on. So all of these services, they are supported by modules that exist and can be added to your Rsyslog configuration files in order to process those logs in the desired way. Now speaking of the configuration files, we're now going to look at how Rsyslog works and how it's configured on a Linux system. And we're going to start with the global Rsyslog configuration file. So let's go back to our terminal. Now what we're going to do in this terminal is we're going to cd into the /etc directory, and this directory contains all of the Linux configuration for various services that the operating system relies upon, and also services that are installed by users. Now if we use the ls-la command, we're going to list out the contents of this directory, and I'm going to scroll up here. We can see we have an rsyslog.conf file, and that's a global configuration file for the Rsyslog daemon. And we also have an 𝗖𝗵𝗍𝗀 directory, and that contains individual configuration for services and for routing between inputs and outputs. We'll look at that one later in the video. To start with, we're going to look at rsyslog.conf, so let's copy the name of that, and I'm going to clear the terminal and we'll use the less command in order to page through the contents of the rsyslog.conf file. So let's execute that and we get the configuration file now. So this is the main configuration file. It contains the global directives, modules, and also references to other configuration files. And these settings are used to control the rsyslog daemon. Now, as it says in this comment at the top here, the default logging rules for rsyslog, they can be found in this file here. It's called 50-default.conf, and that's located in that rsyslog.d directory. We're going to look at that file in a second, but that's where the default logging rules are configured. Now, at the top of this configuration file, we have a section on modules, and the modules that we have here, they're designed to collect logs from various sources. And each of the sources, each of the modules is identifiable with this im prefix. So as an example, we have one at the top here called 𝗵𝗽𝗀𝗽𝗁𝗖𝗓 socket. And what that does is it collects logs from the /dev/log file on Linux. And that one is uncommented. You can see some of the others below here are commented out, including these two here. We have configuration for both UDP and the TCP protocols. So if you need to set up an rsyslog server in order to receive messages from one of those protocols, you can just uncomment those lines if you need that. Now if we scroll down a bit further here, we have the global directives, and here we have a timestamp format configuration that's used as the default for rsyslog. And these settings can all be overridden in the individual service files that we're going to look at in a second. If we scroll down to the bottom here, we have some options on the ownership and permissions for the rsyslog daemon. So for example, the file owner is syslog and the group is the admin group, and we have these permissions here applied to file creation and this permission here applied to directory creation. And finally at the bottom we have a work directory, and this is where rsyslog places spool and state files, and the important one at the bottom here is the include configuration. So by default we're including the files in the /etc/rsyslog.d directory, and we're including any file in that directory that ends in .conf. So let's now go and take a look at that directory. So we're going to cd into that, and it's the rsyslog.d directory, and let's list out the contents of this directory. Now we can see that 50-default.conf file, and that contains the default routing configuration for the rsyslog daemon. And we have a couple of extra files here, and these are for individual services, so the UFW firewall and the cloud init service. Now later on we're going to build a small application and we're going to add our own configuration file to this directory, and that is going to tell rsyslog how to handle the output logs from our custom application. But for now, let's take a look at the 50-default.conf file. And I'm going to use the less command here again, and we're going to look at that file now. Now each line here is a rule that contains certain parts. At the left hand side we have what's called a filter, and that is essentially a rule for selecting the log messages. And on the right hand side we have what's called an action, and that determines where the logs are going to be sent once they've been collected. Now I want to go to the BetterStack documentation again, and we're going to go down here to this section on understanding the rsyslog configuration. So let's scroll down here and we can see a segment of the file that we're looking at. Again, we have these filters on the left and the actions on the right hand side. So let's go down here and we're going to consider one of these lines, and that's the line that begins with cron. Now on the left hand side, the filter is comprised here of a facility and a priority, and they are separated here with this dot. Now on the left is the facility, and that is a subsystem in our Linux distribution that generates log messages. And some examples of these facilities include things like cron, user, daemon, mail, auth, syslog, and so on. Now the wildcard, which is the star here, that can be used to define all facilities, all subsystems in Linux that generate these log outputs. Now if you look at the right hand side, in this we have the wildcard. So what this means is that the priority is set to the wildcard, and that means that this filter is going to get any log outputs from the kern subsystem, and it's not going to discriminate in any way based on the priority of those log messages. Now what is the priority? It's essentially a severity indicator, and some of the priorities in the syslog service include things like debug, info, notice, warning. We have warn as well, which is the same as warning. We also have error, crit, alert, emergency, and panic. So you can use the priority here if you only want to capture the logs of a certain priority level from the facilities that are mentioned. And the last part, as I said earlier, it's the simple part here. It's just determining where to send the log files that are captured with this particular filter. Now let's go back to our configuration file here, and we can see that the facilities in the top line here are the auth and auth private. So any logs generated by those are going to be sent to /var/log/auth.log, and that's a file on Debian-based systems that typically captures user login and logout information. Now you can see the priority for these messages is set to the wildcard, and that means that all of these logs that are generated by these two facilities are going to be sent to this file. And we can see down below here, a couple of lines below that, we have the cron subsystem, and any logs that are generated by cron, and we can see here that the priority has the wildcard, they will be sent to /var/log/cron.log. Now this is currently commented out, so that is not actually going to be applied by Rsyslog at the moment, but we're going to see an example later where we enable that and we can see the logs that are generated by the cron service. Now I'm not going to go through all of these, but these are the default rules that are in this configuration file. If we go down below here, we have some configuration for the mail system. So we're going to look at these because these actually have a priority that's not set to the wildcard. So the subservice or the facility is the mail facility, but you can see we have different priorities. At the top we have info, then we have warn, and we also have err. And that means that the messages generated by the mail service for each of these priority levels are going to be sent to different files, as you can see on the right hand side. Now there are some catch-all log files here, and that's at this section at the bottom. And what these are doing is they are catching a variety of log messages and sending them to these catch-all files, for example /var/log/debug and also /messages. These are two common Ubuntu log files, and the debug log here, that's going to capture a lot of messages that have the priority level of debug. On the other hand, the messages file is going to capture a variety of logs that have the priority of info. Now you can see that the directory for most of these is /var/log. So what we're going to do is look at that directory now. So let's get out of this configuration file, and I'm going to use the ls-la command, and we're going to point to the /var/log directory. And we can see some of the outputs here. We have, for example, a syslog file. We have the auth.log file that's capturing information from the auth facility. And we have the kernel.log file that was mentioned in the BetterStack guide. Now one last look at the configuration file here. We can see something interesting for syslog. So the syslog log file here is going to capture output from all facilities on our Linux distribution, and it's going to capture all priorities as well, with the exception of these two here. So the syslog file in the var log directory is kind of like a catch-all where all of the log outputs are going to be sent, as well as being sent to some of these other log files as well. So we can look at the syslog file if we want to get an overview of all of the logging that's going on, and that's configured using the rsyslog daemon. So let's now see an example with cron. Now you can see at the moment that the cron service here, or the rsyslog configuration for cron, is commented out. So what I'm going to do is we're going to actually edit this file, and we can do that with the nano editor, and it's the 50-default.conf file. So let's go to that file and uncomment the line on cron, and then we can save that file, and we need to now restart the rsyslog daemon. So earlier on we used systemctl and we were using the status verb in systemctl. What I'm going to do now is use restart, and that's going to restart the rsyslog daemon. And if we look at the status of it after restarting, what we're going to see is that it's now running, and it was started 8 seconds after I ran this command. So let's go back to the terminal now, and if we look at the var log directory that we looked at earlier, we can now see that there is no cron.log file at the moment. But hopefully we're going to add a cron task now, and that's going to generate some output that we can then see in this cron.log file that rsyslog will send the cron logs to. So let's go to the user's cron tab. We can do that with the cron tab command, and we're going to edit the cron tab, so we can use the -e flag, and we're going to go to the bottom of this file. Now I have some cron tasks from an earlier video. I'm going to comment those both out, and at the bottom we're going to do something very simple, and we're going to do it every single minute using that syntax there for the cron expression. We're just going to echo hello world to the terminal, and we're going to do that every single minute using the cron daemon. So once we've done that, if we look in the /var/log directory, we now have this cron.log file. So let's actually look at that file. So I'm going to cd into var/log, and then within that directory we can use the cat command to look at the cron.log output. And we can see some of this output here, for example this echo hello world. That output has come directly from what we just added to the cron tab. So it's taken that output and it's stored it here in the /var/log/cron.log file. So why has that happened? Let's go back to the previous directory, which was the rsyslog.d directory. And what we're going to do again is we're going to look at the 50-default.conf file. And what's happened is that the output from the cron facility, that has been captured by rsyslog and it's been sent to this destination here. And that's the cron.log file that we just looked at. And it should also have been sent to the syslog file. So what I'm going to do is go back to the /var/log directory. And in this directory, let's look at the last 50 lines of the syslog file. And we can see the cron output here for the hello world command. So rsyslog is capturing our logs and it's sending them to a variety of destinations based on what's configured in that 50-default.conf file. Let's now move on and we're going to write our own small service and we're going to use rsyslog to intercept the log outputs and redirect them to a different source. So what I'm going to do is go to my home directory, which we can use this command, cd with the tilde. And in my home directory, I'm going to create another directory that we're going to call rsyslog demo. Let's cd into that. And what I'm going to do is create a small Python API. And we're going to use the Fast API framework in order to do that. So let's create a Python virtual environment using the 𝗵𝗽𝗀 module. And I'm going to call this 𝗵𝗽𝗀 rsyslog demo. Once that's finished, we now have a Python virtual environment here in this directory. We can use the source command to activate that virtual environment, and it's in /bin/activate. Now once we've activated the virtual environment, we're going to install a couple of Python packages, and that's the Fast API and 𝗖𝗵𝗽𝗀 packages. These are going to be used to create an API in Python, and this is going to be a very simple API just to demonstrate how we can use rsyslog to take our log outputs from that application and redirect them to a different location on the system where we can centralize and analyze those logs. So now that these packages have been installed in the virtual environment, we're going to create a directory called source, and that's going to contain the code for this API. And in that directory, we're going to open this directory in VS Code in order to create some files and write the code. So I've now got VS Code open in that directory, and we're going to create a file that we're going to call api.py, and that's going to contain our Fast API application code. And I'm going to paste in the code for a very simple Fast API endpoint here. So we import the Fast API object and instantiate that on line 3. We then create a Python function that's decorated with the app.get decorator, and that means that any HTTP GET request to this path here is going to activate this function, and it's going to return this dictionary here, which is going to be converted to JSON by Fast API. So a very simple API function here. What we're going to do now is actually start the Fast API server so that we can look at this. So let's go back to the terminal, and we're going to use 𝗖𝗵𝗽𝗀, which we just installed, and we created a file called API, and we have an app object within that, so we can use that syntax there, and we're going to use the -- reload flag in order to reload this application whenever we make a change. So once we've used 𝗖𝗵𝗽𝗀 to start this server, we now have an application that's listening on localhost 8000. So let's go to the browser, and when we go to localhost 8000, you can see we get back the dictionary or the JSON content with the hello key and the world value. What we're now going to do is add some basic logging to this application. So let's import the Python logging module, and at the top of this file we're going to create a logger object, and we're going to use the logging.get logger function to do that, and we'll pass the name of this module as the parameter. Once we have a logger, we're going to create what's called a handler, and if you want to know more about this, we have a video on the Python logging module that should be appearing on the screen now. Now we're going to output our logs to a file, so we're going to use the logging.filehandler object, and let's call the log file app.log. We also need a formatter for this logger, so we're going to use another construct from the logging module, and that's the logging.formatter object, and we pass a format to that, which is a string, and we can use these directives here. For example, if we want the timestamp for the log output, we can use the ASC time, and we can also get the log level by using the level name property as well. And we also have a message that's output when we use the logger.info call, for example. So we're going to output that message here as the last part of this formatter. So now we have all the objects that we need. We're now going to set this formatter on the handler. We can do that with the handler.setFormatter method, and we can pass our formatter into that. And then we're going to add the handler to the logger object. So the logger object has a property called handlers, and that takes a list of these handler objects. So let's pass a list containing our object. And the final thing I want to do is set the level on the logger. We can do that with logger.setLevel, and we're going to set the level to the info log level. So we now have a logger here in Python. What we can do in our FastAPI application and in these route functions is actually use that logger to send some logs to the configured handler. So let's do that just now. What I'm going to do is set up a dictionary in Python, and we're going to log out the data from that dictionary, and that's going to be then sent to this app.log file. Now what I want to log out is the IP address of the client that sends the request to this API, and I also want to get the method of the request. For example, is it a GET request or is it a POST request, and so on. So at the top here from FastAPI, let's import the request object. I'm going to copy that, and we need to inject that into the FastAPI function. We can do that as a parameter to the function here. So we give it a parameter of request, and we're going to give it the type of the FastAPI request object. And we can use that request object, for example, to get the request method. So we can set that to the request.method property. And if we want to get the IP address, we can use a different value here. It's going to be request, and we access the .client property on the request. And we can get the host, which is another property here on this client object. So now that we have our dictionary of data, we're going to use the logger log level methods now. So for example, logger.info, and we can pass the data into that, and I'm also going to pass it in as extra data as well. And again, if you want to understand this line of code, check out the video we did on the Python logging module. So what I'm going to do now is go back to the terminal. We still have the application running here. The 𝗖𝗵𝗽𝗀 server that's serving this API is still running, so we can go back to the browser, and I'm going to refresh this page, and we're still getting back the same response here with this JSON data. Now I'm going to bring another terminal onto the page, and we're going to list out the directory contents of this directory that we've been working with. We can now see that we have a .log file here. It's called app.log, and that is the file that we configured in VS Code. So if we go back here, we can see that the file handler that we used is outputting the logs to that file. So on VS Code, let's have a look at the app.log file. We can see the log output here. It contains the timestamp on the left, and it contains the log level of info here in the middle, and then we have the message containing the method and the IP address. So our logs are being generated in this FastAPI application, and they're being sent to the app.log file. Now the next goal that we have here is to use Rsyslog to collect the logs that are generated and stored in the app.log file here. And we want to take them from that source, and we want to output them to the /var/log directory and into a text file that has a particular name that we're going to configure in the Rsyslog configuration files. So what I'm going to do now is go back to the terminal here, and I'm going to stop the FastAPI application, and we're going to go back to the Rsyslog configuration directory. So it was /etc, and then it was the directory called rsyslog.d. And if we list out what's in this directory, we have the files that make up the configuration for different services and the defaults here in the 50-default file. What we're going to do is create a new file for our own application, which is that FastAPI service. So what I'm going to do in this directory is use the sudo nano command, and we're going to create a new file here, and I'm going to call it 51-rsyslog, and let's call it -fastapi.conf. And that takes us to a new file here, which is currently empty. And it's here that we're going to add the configuration that will determine how Rsyslog will process the logs from our FastAPI application. Now I'm going to go back to the BetterStack documentation now, and there's a section here on getting started with Rsyslog. And as it says here, now that you have developed an application to produce logs at regular intervals, you can use Rsyslog to read the logs from a file and then transform them into syslog messages that can be stored in the syslog file. That's what we're going to do now. And what I want to do is look at the configuration here that we have. I'm going to copy this, and I'm going to paste it into the file that we have on the terminal, and we're going to explore what this is doing, and we're going to change one or two of the settings. So at the top we have the global directive, and this is configuring the working directory where Rsyslog is going to store its state files. And these state files will allow the Rsyslog daemon to track the parts of the logs that it's already processed. So that's a global setting. What we then do for our service is we load a particular module, and the module that we're loading is the module that allows Rsyslog to read logs from a file. We then have a section below here on defining a new input that tells Rsyslog how to read the logs from which particular file. So we have the type of IM file, that's the module, and the file itself here is the file that we want to collect the logs from. Now what I'm going to do is change this. We're going to use the directory where our FastAPI application is living. So we want to set this to the path to this app.log file. And we can see that path in VS Code. It's in the user's home directory. It's the rsyslog-demo directory /source and then app.log. So let's set that up here in the configuration file. It's going to be in the home directory, and it's going to be in my users directory and the rsyslog-demo directory within that. And finally in the source directory it's going to be the app.log file. And below that we have some other parameters for the 𝗖𝗵𝗽𝘀 module, and we're giving these a tag of file logs and some other parameters below. Once we've done that, we can go to the bottom section where we send the logs with the specified tag to the console. So what we have here is a conditional expression that checks if the tag is equal to file logs, and if that's the case then we specify an action, and the type here will send the collected logs from the above input to an output file, and that file is /var/log/syslog. So we're expecting our application logs to be forwarded to the syslog file once we set up the rsyslog configuration for this service. So what I'm going to do is now save this file, and once that's saved we're going to go back to the terminal, and again just for a sanity check we'll ls the contents of this directory and we can see our new file here. We now need to restart the rsyslog daemon. So let's use the sudo systemctl command and we're going to restart rsyslog. So we're going to use the restart verb, and it's going to be the rsyslog daemon. Once we've done that, what we're going to do is go back to our application directory, which was at the home directory and in the rsyslog demo directory and the source directory within that. And what we can do here is restart the 𝗖𝗵𝗽𝗀 server, and then I'm going to go back to the browser and refresh this application a few times. So that's going to send me back the JSON content from our FastAPI handler function, and that's going to generate the logs that are defined here in the application function with this logger.info call. Those are going to be sent to the app.log file, but now we expect that the rsyslog daemon is going to be monitoring that file, and it's going to be collecting the logs that are sent to that file and redirecting them on to the syslog file that we have on the system. So let's now check that out. If we go back to the terminal here, I'm going to stop the 𝗖𝗵𝗽𝗀 server and we're going to go back to the /var/log directory. And if we ls this directory, we have the syslog file here. So let's tail the contents of that file, and we're going to get the last 50 lines. And we can actually see here that we have the outputs from our FastAPI application. And this contains the timestamp, the log level name, and it also contains that data as a dictionary containing the HTTP method and the IP address. And we can also see the tag that was added here from rsyslog. This is the file logs tag. So again, we have an application that's generating logs, and that's using FastAPI in Python, but this could be using anything. It could be using PHP or Go or Node.js. And we've set up rsyslog to collect the logs from those locations and forward them to the syslog file. And that's the crux of what we're going to do here with rsyslog. We've got an input, which is our application log files. We've got the rsyslog configuration that's pointing to that input, and we have an output location where the logs can be consolidated and centrally analysed, and that's the syslog file that we have here on the system. Now just before we finish this video, if we go back to the BetterStack documentation, we have also options for transforming logs with rsyslog. So for example, we can format our log outputs to JSON, and that can have its benefits because JSON is a structured format and it's machine parsable. And in order to transform logs to a particular output, what you can do is define a template in your rsyslog configuration files. And if you want to know more about that, you can check the documentation that we have here on how to do that. And the final thing to show, if we scroll down a little bit further, is that we can use rsyslog to add custom fields to the log output when it's forwarded to its destination. And you can do this using what's called constant statements, and these statements allow you to insert fixed values into your log messages. So let's see an example of that. We have a template here that's outputting JSON data for our logs. So that takes the logs from our input source, it reformats that or transforms it to JSON data, and then sends that on to the destination. What we have at the bottom here, as well as the properties above, is a constant. The outname defines the key in the resulting JSON, and the value that we have is hard-coded here, and that's the value of dev. So you can enrich your log outputs using rsyslog, using these constants that you define in your templates. And if you're interested in how to use rsyslog with Docker, there is a section of this BetterStack guide that will go into some detail on how to do that. If you're interested in a video on that, let us know in the comments. But that's all for this video. In this video we've seen the basics of the Rsyslog daemon and how it collects logs from various sources and optionally transforms those logs and then forwards or redirects those logs out to various destinations on your Linux system. And in between that input and output process, there is the optional ability to transform and enrich the logs using Rsyslog as well. And what we did in this video, as well as showing Rsyslog itself, we developed a very small fast API application that sent some logs to the file system here and into a file called app.log. And we then set up Rsyslog to inspect those logs, collect the logs that are generated and sent to that file, and then output them to a new destination. In this case, that was the syslog file. So we've covered a lot in this video. If you're interested in more content like this, let us know in the comments. And don't forget to give the video a thumbs up and subscribe to the BetterStack channel if you're interested in more of this type of content. Thanks again, and we'll see you in the next video.